Welcome to Subatomic Tanvi.
Hi everyone.
It's cold in here. I thought this was summer.
It is summer. I turned the thermostat down because what we're talking about today is really chilling.
Ooh, I like it already. Like how chilling.
Like absolutely chilling, or as we say, absolute zero chilling, minus 273 degrees Celsius.
Oh my god, that must be freezing. Colder than Antarctica or even Mars, probably?
Absolute zero is the coldest possible temperature in the universe. When you cool a bunch of subatomic particles down to absolute zero, you actually get the fifth state of matter.
The fifth state of matter?
Yep, solid, liquid, gas, plasma, and a Bose-Einstein condensate.
Wow. So, what is the Bose-Einstein Condensate?
So, when the temperature drops, bosons start to cluster together and then they act like one giant superparticle.
And what happens if they become one giant superparticle?
Really weird things, actually. One thing is that they could become a superfluid. Superfluids are fluids that flow without any friction. For example, let's pretend that there's coffee that's a superfluid. So you're just stirring that coffee, then even after you stop stirring it, the coffee is going to keep on swirling because there's no friction. But on the other hand, for a fluid that's not a superfluid, just a regular fluid, it like water, if you stir water and then you stop stirring it, it'll start to slow down the swirling and then eventually it'll stop due to the friction.
So, if I have a cup full of Bose-Einstein condensate and I swirl it with my hands, it's going to keep swirling and swirling
That's correct.
forever?
That's also correct.
That's a pretty slippery situation. So, what else is weird about them?
So, even though superfluids flow without any friction, they exhibit another kind of motion too. They're called quantum vortices.
Quantum vortices? I just thought I understood everything you said.
So, quantum vortices are tiny tornadoes that form inside of a superfluid. In a regular fluid, these small tornadoes can be any size and they can be spinning at any speed. But in a superfluid, they those tornadoes, they need to be spinning at a specific speed.
Wouldn't the tornadoes cause the superfluids to spill out?
Not quite. Here's where it gets weirder. So, imagine a straw that's sealed at the bottom. That straw is filled with liquid helium. Then, once the temperature cools down to absolute zero, something really cool and amazing happens to the liquid helium inside the straw. It just erupts out of the top of the straw. This is called the fountain effect.
Wow, that defies gravity.
Yeah, it does. Imagine you're just staring at a cup of coffee and you're not touching it in any way, and the coffee just climbs over the edge of the cup.
You mentioned liquid helium. Why did you choose liquid helium?
Because liquid helium is actually a type of Bose-Einstein condensate.
Sounds like Bose-Einstein condensates are not just cold, they are really cool.
They are indeed.
That's wonderful. Thanks for another amazing episode, Subatomic Tanvi.
You're welcome. Bye, everyone.